All right, you might ask, how do the astronomers know this? And we're going to show you a clip from Journey Toward Creation that talks about what astronomers do and how they observe the past. That phrase, Hugh, is a funny one. You observe the past. How in the world do you observe the past?
Well, light has a finite velocity, so it actually takes time from light from distant galaxies to get to our telescope. So it means we're seeing those galaxies as they were when the light left, not as they are right now.
Yeah, so when we see the sun, it's actually, we're seeing the sun as it was 8 minutes ago because it takes that time to get here. And as you go to other stars and galaxies, it's further away, it takes time to get here. Right. And you can actually observe this as you adjust your telescopes.
Right, we can actually see right back to virtually the beginning of time itself.
That's what I want to show you in this clip. Watch this.
This is the Keck Observatory, the world's largest optical telescopes. Together, these two telescopes have 8 times the collecting area of the Mount Palomar telescope and more than 30 times that of the Hubble Space Telescope. The Keck telescope has 36 independently driven mirrors. Computers control the movement of these mirrors so that they work in sync as one gigantic 400-inch telescope. It's also very precisely figured down to a molecule's thickness. With sensitive light and radio wave gathering instruments like this, we can look out billions of light years into space to the very limits of the cosmos itself. But as we look out into space, we're also looking back in time. This is where astronomy is unique among the sciences because it alone directly observes the past.
As a matter of fact, astronomers are always observing the past. Light waves, radio waves, and all other kinds of electromagnetic waves may seem to reach us instantaneously, but they don't. They seem to because they travel so fast. Light speeds through space at 186,000 miles per second, fast enough to circle the globe 7.5 times in a second. When we look at the sun, 93 million miles away, we're seeing what it looked like when the light left it about 8 minutes ago. Likewise, when we look at the moon, we're seeing it as it appeared about 2 seconds ago. When we look out to the stars, we're seeing them as they were thousands, millions, even billions of years ago. The farther away an object is, the longer ago its light began its trip through space. The distance light covers in a year, about 6 trillion miles, we call a light year. Light years offer a more convenient method for indicating vast distances. The most distant galaxies ever detected by astronomers are about 13 billion light years away. That means the light from those galaxies took 13 billion years to arrive on Earth. As we gaze at this galaxy, we're looking back in time at how it appeared 13 billion years ago.
That clip is fantastic, Hugh. And let me ask you this question. With all of the advances in science that we have, how far back can you now look with these telescopes?
Well, the Keck gets you back to when the universe was about 5% of its current age. But now we have instruments in radio astronomy that can tell us what the universe was like when it was 100 billionth of a trillionth of a trillionth of a second old. That's how close we can get to the actual cosmic creation event. And this is where we get the most compelling evidence that indeed the universe must have had this space-time beginning.